the module on using new definitions. So I'll just write it, we'll call it new definitions. And these are problems that you see a lot on things like the SAT and other standardized tests. And they're really just to make students comfortable with strange looking operators. So we might say something like, we might define some operator. Maybe it's this diamond looking thing. We have an A, B, C, D. And we'll define this as being AD minus BC. And then we ask the student, maybe 3, -1, 2, 5 is equal to that. And we could even write given if you want. Given that, what is that equal to? And then for the, we just solve the problem. We just say, well, that thing, let me write that thing there. 3, -1, 2, 5 is equal to, and we could even color code it a little bit. We could put the 3 in blue, so it'll become 3 times this 5. You don't have to color code it, but if you want to, it'll make it more easy for students to understand. Minus b. So we'll do b in maybe that color. So minus -1 times c times 2 times 2, which is equal to, is that 15? 15 plus 2 is equal to 17. So 17 would be the choice. The other ones could just be random numbers above and below 17. Doesn't have to be above and below, but you get the idea. Now, this could just be one definition, and we could define this definition in multiple ways. We could define that kite-looking thing instead to be, instead of AD minus BC, it could be A plus B, maybe plus C over D, whatever you want. In fact, you don't even have to use all of the letters. Now, other definitions that you might want to use, maybe we have something like a peace symbol. Maybe we have a x, y, and a z. And we say this is going to be equal to x plus 1 over y plus 2 plus z. Define it any way you want. You might just want to throw a lot of different possible definitions in there. We just want a lot of variation so students don't get bored, and so there's a lot of different exposure to things. We can define function definitions more simply, or operators. We could have x, maybe star or asterisk y, and we could say that that is equal to x. We could say that that is equal to x, x plus y plus xy. And then we don't even just have to do a simple question, what is 5 star 2? We could ask them, what is 5 star 2 star 3? And then, of course, the hints in this, we would say that is equal to what? And then, of course, the hints here, you'd say 2 star 3, so 5. So this is equal to 5 star. And then instead of the 2 star 3, you'd say that's 2 plus 3 plus 2 times 3, which is equal to 5 star 2. This is 6 plus 5, 5 star 11, which is then equal to 5 plus 11 plus 5 times 11, which is whatever. That's 16 plus 55, which is what, 71. So the idea is you can actually make them use the operator multiple times. And in fact, that would be a pretty cool way to do it. If you really want to get really fancy, you can define multiple operators in the same session or in the same problem. So you can have that definition, and then maybe you also have something like this. I think this in general would be a pretty fun module for students to do. And then we could write something like a square b is equal to the larger of a and b. Larger of a and b. So then if you have something, and I'm just making things up, these definitions, it could be the larger of a and b. It could be, we could just put a b there. It's always going to be b, something as simple as that. It could be something like a b minus bc, or minus b, well, that's just going to be 0, or minus b could be just like that. So be creative in what the operator might mean. This xyz, instead of doing this, it could be equal to xy plus yz plus xz. It has some nice symmetry to it. So whatever you want, be creative in how and what these definitions are. But you can imagine if you have these two definitions right there, then we can ask the students, you could ask the students something like, what is 5 square 7 star negative 1? Where first they have to do 7 star negative 1, and then they have to apply that to 5 square that number. So you can imagine there's kind of endless possibilities here. We want enough variation so they don't see things too often, or maybe we want at least 10 variations. So over the course of 10 problems, you're likely to see different things every time.